Hello, and welcome to the American University in Cairo's Video Game Workshop Series, hosted by the Computer Science and Engineering Association, and presented every Monday 5 to 7 in the Computer Science Labs by me, Karim Abdelhamid, and Don Omar El-Bahedi. Today we're going to be talking about blueprint and level design. Now, first you may ask, what exactly are these? Well, level design is the design and creation of video game environments. Basically, it's the spaces that you play in video games. It includes many different fields, including lighting, architecture, and gameplay. What is blueprint? Blueprint actually has nothing to do with level design, and has nothing to do with conventional blueprints. Essentially, blueprints, are a visual scripting language that basically form something like flowcharts. Now, they're for artists and people who need more intuitive ways to program. They're much faster but much less efficient at what they're supposed to do. So first, before we actually get into blueprints, I want to mention the fact that this video will be split into two parts: the blueprint section, which is this section, and then the level design section. So first off, before we actually look into blueprint, let's try and install the engine that we're going to be using. You should already have this installed, but if you haven't, let me just get past these. You have to try and install the Unreal Engine. So first off, you want to go to unrealengine.com and then press on Get Unreal. Once that happens, you can either sign up or sign in. And once you've signed in, you should be able to download it. Now, I already have it installed, so I'm just going to go and run the Epic Games Launcher. So this is what you should see first, okay? You should see the Community tab. But none of this has much to do with us right now. We want to go to Library. Here you can see the projects that we're working on, any projects that we have installed, and the engine versions that we have. So first off, we want to either install a new version or launch the version that we have now. I'm going to launch version 4.8.3 because that's the one that I believe that we were using in class. Also, I don't have the other one installed. Now, once you have that loaded, you should either see the Projects tab or the New Projects tab. Either way, make sure that you're in the New Projects tab. Then try and go to Third Person. Ensure that Starter Content and Maximum Quality are on. Tell the program where you want to store it and its name. And then just create project. For this session, we're going to call it the Video Game Workshop project. And create. Now that we've started up, let's get right into it and create a blueprint file. First off, click on this content browser and go into Blueprint class. Now we want to create an actor. Essentially what an actor is the basic thing that you can put into the world. There's nothing more basic than this that you can put into the game. But above that, there are pawns and characters and player controllers, as well as game modes, actor components, and scene components. Components, I believe we've explained last time. A game mode is essentially the rules of the game, and a pawn, character, and player controller are all assets that can move as characters. So let's create an actor here and call it whatever we want. Let's call this rotating chair. Now, if you double click it, our blueprint will open up. It's our blueprint class. So now that we've created our blueprint class, let's actually start adding stuff to it. Now, since a blueprint class is basically an entity, we're going to try and add some components to it. And if you don't remember what components are the basic building blocks of an entity. So if you were looking at humans as an analogy, our components would be our organs, our hearts and brains. Now let's try and add something that we can see, because right now this sphere doesn't actually exist, it's just so we know where the center is. So let's create a static mesh by going into add component and pressing static mesh. Now once we select static mesh, we can choose what mesh we want to add to it. Try and remember that a mesh is basically a network of polygons connected to each other. So if we press on the static mesh on none, this drop down menu here, we can search for whatever we want. So let's look for a chair. Remember that this is going to be restricted by the assets that you actually have. Now let's try and add something to collide with this, because right now it's only visual. You can only see it, you can't really interact with it. But if we create a sphere collision and align that to this, or more correctly parent it to it, whenever the static mesh moves, the sphere will move. But with the sphere we can also align it, change the size over here in the sphere radius. So let's make it, let's say 100, no, that's too big. Let's make it 64 or so. So now the player can actually interact with this chair. Now we still want to make the chair rotate. Let's look up here. Here you can see that there are 3 tabs. There's the viewport, the construction script, and the event graph. Essentially what the viewport is it's basically lets you see the actual components and how they look with each other. The construction script allows you to create stuff using Blueprint in not in runtime, when the level is being created. So this does not happen every time you launch the game, which leads to a lot of performance benefits, but it's not also something that you can't do but if we want to look at the blueprint, we can just go here to the event graph. Here we can see what blueprint is. It's essentially a bunch of nodes that are connected towards each other to create a flow and create actual running code. Now for this session we're going to begin by creating a rotating chair. So what we want to do first is add a component. If you don't remember what a component is, it's basically one of the building blocks of each entity. Okay. So if we have, for example, a sphere collider, that's an essential component. If you look at an analogy with humans, a component would be like the heart or the stomach. But enough of that. Now that we've created a sphere collision, let's go ahead and add a static mesh and put the static mesh under the sphere. What this basically means is that when the sphere moves, the static mesh will as well. Now let's give the static mesh a look so that we can see what we're doing. Remember the fact that a mesh is essentially a group of polygons connected to each other. So we're going to look for, yes, the chair. Now you can look around using the same controls as we've mentioned in the last video, but now that we can see the chair, let's try and fix this sphere collider. Essentially what the sphere collider does is it essentially does the physics for the chair. Okay, there's not many more easy ways to explain it. So all of the collisions happen when you mess with the ship. Now that we've added this chair, let's look up here. We can see 3 tabs. The viewport, where we can see the components and how they interact with each other. We can see the construction script, which is basically script that runs while the game is being built. This leads to a lot of performance benefits, but also leads to a few issues that it can't actually run in runtime. Besides the construction script, we also have the event graph. The event graph is basically everything that runs at runtime, and runtime is when the game is actually running. So if you look here, we see 3 nodes. We don't need these nodes, so we can either box over them by clicking and dragging, or we can click on each one and pressing control between them, and then pressing delete. Because like I said, we don't need them. Then we also have event tick. Event tick basically is a node that's for entry. It's the first node in the sequence. And it basically runs every tick, every frame, which is usually 1/60th of a second. As you can see here, our program is auto-saving, so you don't have to worry usually about losing any information. Now, the first thing that we want to do is try and create a chair, or make the chair rotate actually. So let's first bring out this, okay? This is the executable timeline. When this goes to a different node, it runs the next node in the sequence. So let's drop it anywhere and create a set rotation, relative rotation static mesh. As you can see, 2 nodes have automatically been created. A command node, which sets information, and a get node, which gets information from, well, our variables over here. Our variables include the components, by the way. So we want to, first of all, input information for the rotation. As you can see, this is color-coded. So we have white for the execution timeline, blue for whatever classes and references that we have, and finally purple for rotation. Okay. Now let's pull this out and click on Make Rot to make a rotation. And let's just put in 45 in, actually 45 in the pitch, just to show you. Keep yaw at 0. So let's compile this so that we can see it in action. And then just drop the rotating chair anywhere, just anywhere, and press play. You should see it at an angle, which means that it's working. We have the code that we wanted. Then let's just go back here. Now that we've created the xrot variable, let's begin to use it by putting it into yaw. This gets whatever our xrot is and pushes it into the yaw value. Let's put this back to 0 by pressing 0 and then enter, so that it rotates along the center axis. It rotates how a chair would normally rotate, basically. Now we need to set xrot. So let's move this back a bit. Now, first I need to explain what delta seconds is. This pin for delta seconds basically talks about the difference in time between every 2 frames. If we know that, we can create a consistent look between frames. So first off, let's drag this off and multiply it. So if we search mult, M-U-L-T, we can find float times float. This allows us to multiply 2 float values. Let's multiply it by the speed we want it to go at. Let's say 15. Let's drag this off again and write add or plus, whatever you prefer, and go into float plus float. This allows us to add 2 float variables. Now, these 2 nodes basically allow us to find out the difference between every the difference in rotation between every 2 frames. Here we can actually add that to our previous value by clicking on xrot and dragging it over here, so that we have the new float value coming out of here, the new value of xrot. Now we can plug this into here and remove this if we want, so that our code is cleaner. But we also have to drag this over here so we can set the xrot. Once we've done that, let's put this in here and this in here to add this to our timeline, to our execution timeline. Now let's compile and press play. We can clearly see that it's rotating. So once we've exited by pressing the escape button, well, basically we finished the first blueprint project. Now let's move on to a different blueprint project. Probably a lot of you were wondering about construction. That is actually very interesting because it allows us to make the artists' lives easier when creating content. So let's give an example. Let's say you want to create a wall, but you don't want to create all of the pieces of the wall in the exact way that you have to put it inside and blah blah blah. It's a lot of effort. Instead, let's try make a wall using a line that expands from that. That makes sense, right? It's a lot easier than the alternative. Now, how do we do that? Of course, we use our friend Blueprint. So let's create a new blueprint, another actor, and let's call it wall, for example, just for the sake of it. Once we open that, let us go into construction script. We don't actually need any components for this because we're going to be creating it ourselves. Oh, no, we actually need one, sorry. First create a spline component. The spline is basically the line that we're going to follow. So let's place our wall in the game to see how the spline will work first. So let's compile and let's place an instance of the wall inside. So aside from this big annoying sphere that takes up a big amount of space, we can see vaguely two squares here, or more like one square, but whatever. There are two squares here connected by a line. So these two squares represent control points. They're basically points through which the line will go that can also have curves go through them. So let me explain it this way. Let's say you have a graph of f of x, okay, and f of x is really confusing, but you know 2 points, okay? Those would be these 2 points, except for that we can control the entire graph using it. So let's select the second point and press Alt. Then let's drag off any one of these axes, let's say the green one, and move it. Here, something has happened. You can see a new control point and the line trying to match these 3 control points while remaining curved. Now, you can change how these lines curved, but that's a story for a different day. Now let's just continue creating the wall, making an interesting pattern with it by continually pressing Alt on it and dragging wherever we want the wall to go. So basically our wall will follow this spline. Now the way we want our code to work is that we will build the wall with chunks, okay? So between the first point and the second point will be the first chunk. Between these 2 points will be the second chunk. Actually, let me just move this a bit. This will be a chunk and this will be a chunk. So let's actually go in and start programming these chunks, or at least the first chunk. So let's first go into the construction script blueprint menu. Sorry, blueprint tab. Now we're going to want to create a function. A function is basically a small piece of code that can be copied and used again and again. So let's click on plus function and name it whatever we want. Let's create create wall seg for segment. Now we're going to need some information in here. What information would we pass? Let's go back into the map And let me explain it this way. If we want to create the wall between these 2 points, we're going to need to know the identification numbers of the points. Now, we could pass both identification numbers of the points, which would be 0 and 1, and this would be 2 and 3 and 4, or we could just pass this and assume that the next one is 1. So let's go back into wall, add a new input, and make it an integer, which, as you know, is a whole number, and call it whatever we want. Let's say wall ID, whatever, or point ID, just so it's more straightforward. Now we want to actually create well, what we see, the visual segment of the wall. So first off, let's branch this off and say create spline mesh. No, spline mesh. Yes, add spline mesh component. Once we've done that, we're going to actually need to deal with some information for the spline mesh component. First off, let's create let's set the static mesh as we did with the chair. This time let's make it a cube mesh. So it's going to be a box wall, okay, a rectangular wall at least. Now we have to set the beginning and end points of the spline. So let's drag this off and say set location. We're looking for set start. Yes, sorry. Set start and end. There are a lot of these commands. It's going to be impossible to memorize. You just end up doing it by intuition. Anyway, so as you can see, there are 4 pieces of data. You probably expected 2. The start and end positions and the tangents. The tangents are basically the angles of the wall. So we know how it's going to bend. So it can bend similarly to the spline. Now, you're probably thinking that it might be hard to get this data. Actually, it's right in the spline. So let's get the spline. Then let's get the tangent, location and tangent at spline point. Yes, that's what we're looking for. Let's actually create 2 of these. One for the start and one for the end. Let's delete this and put this over here so that it's cleaner. And let's pass this in over here. So we know the first point that we're trying to pass. Now we also want the point after that. So let's drag this off over here and press plus. You should automatically get integer plus integer. And automatically it should be 1. So that's exactly what we want. We want the point plus 1. So if it's 0, it's 0 and 1. Now this is automatically the information that we need. So let's just put this right in here. And compile. I know what the problem is. We set the start and end without actually saying what we want to set the start and end of. So let's basically drag this here, and then the code will know that we want to set the start and end of the spline mesh. Compile and go over here so we can test. Now if you press on the play icon, you should be perplexed by the fact that there's nothing there. Basically, we forgot to actually call the function. So let's go back to wall, construction script, and here you can see that there's nothing actually here. We have to drag this over here, place the execution flow so that we know that this is the only thing that we're going to do. Make sure that this is 0 or whatever point that you want to create, and compile it again. When we check here, you should actually see that there's something there. So this is basically our very, very small wall. We can actually deal with the scaling and offset later. But first, let's create the rest of the wall. So we're going to go back into our wall script, and basically what we have to do is create the other segments using the same code. So let's drag this off and create a for loop. Not a for each loop, a for loop. Basically what a for loop does is it has a start and end index. So let's set it manually for now. 0 and I think it's 3. Now let's drag this index off of here. So for the first number, 0, it's going to pass 0, then 1, then 2, then 3, and that's all the code it should pass. So when we compile this and go back here, we can see already that we have the wall, although because it's so crude, it doesn't look very good. If we drag this over here, we can see it's much more flowy. Now, if you're wondering why it's so rigid to start off with, that's because our cube mesh isn't really made for this. Normally, these kinds of meshes that would go along splines would have sub-segments, so that could curve with the spline. This doesn't have that, so just curves at whatever segments it can find at the actual corners. Now, the code that we have now makes sense, but let's improve it a bit. First off, this only works for 3 segments. What if we have 4? So basically what we want to do is, let's get the spline, drag this off of here, and get num spline points. Okay? Let's subtract 2. I'll tell you why in a second. And pass this in. Compile, and it works. Now the reason it works is because here you can see we have 5 points and 3 segments. Basically we want to start at this point, the beginning point, the second point, or the first point, sorry, the second point, and the third point. We do not need a segment that comes off of here, and the last segment is discounted anyways. So basically we have all of the data that we need. Now that I've explained to you what blueprints are, it's much easier to explain the actual information that goes into it. Essentially, nodes are commands and processes that you can deal with. The program is created using the flow, as we've seen, between 2 nodes. Pins are the inputs and outputs of each node, and the types of information that we pass is obviously color-coded. We can get and set nodes for local and global variables, and loops allow us to deal with code that is repeated. Functions, I've explained, are subprograms that we can use again and again. Oh, I haven't explained this. Let's go into this. Reroutes are essentially a way to organize your code. So let's look into create wall seg. Let's say that we don't like how this looks. We can reorganize it using the reroute. So let's drag this off of here and create, oh, here it is, add reroute node. Now all we have to do is drag this over here and drag this over here. And we can already see that our code is much cleaner. And if we compile, it works in exactly the same way. Reroutes are, as I said, used for the organization of the code. And here's another point that I didn't get into. Now, we want to be able to set a different mesh, let's say a mesh with actual segments in between, for the wall. So let's go into here. So if we want to set the mesh of what we're dealing with, let's drag this off of here and set static mesh. Now let's drag this off and promote to variable. Now we have a new variable. Let's go up here and name it. So wall mesh. Now we want to be able to edit this at will. So let's make it editable over here. Now, if we want to set a default value, we're going to have to compile it first. So let's compile and press here and go into cube mesh. If we compile again, I'm sorry, I just realized that again we have the same issue that we had in the beginning. We have to connect this over here for it to work. So if we compile, it should work now. Yes. And we can set different meshes that will look very ugly, but we can deal with it either way. So there we go, our own strange wall. But it works. We can deal with any mesh that we could possibly add, and it'll try and work. Some meshes are really suited for this, but unfortunately you do not have those meshes unless you download them separately. So for now, let's go back to cube mesh. What I just explained is a way to have editable variables that you can put in your code and can be edited by the artist. Now, moving on. Well, essentially, blueprints have some of the features that other programming languages have, such as object-oriented ones, including classes, inheritance, and functions. Essentially, classes are a way to get the same functionality from older blueprints and put them into newer blueprints. Well, that's what inheritance is. A class is an individual blueprint. It also allows you to debug, as we've seen. It tells us what the errors are and where they are, and we can watch certain variables to make sure to check their issues. We can put almost anything in blueprints, but not everything. Some things need to be coded in C++, and some things will be very inefficient with Blueprint. As I've shown you, there are runtime and construction scripts, as well as many other different kinds of scripts, including level scripts and things like that. And that's essentially it. Finally, I'd like to go over one special kind of blueprint: material blueprints. We're going to be talking about this again in the future, but essentially what a material is, or also known as a shader in technical speak, but it's basically a series of information about something that you're going to render. So let's say the water or the sand that you can see in this picture, or even the sky. It all has its own information about how to be lit. There are several inputs, including base, color, metallic, specular, roughness, opacity, normals, and displacement. We talked about this all in the previous segment. And there are some special kinds of things that we have to deal with when dealing with materials, including grass and stuff like that. And finally, one of the most important things when we deal with material blueprints is texture samples, so that we can import parts of textures to deal with. Here is an example. You can see here that we have the material and we have information put into pins, as we've seen with the functions, that go into the blueprint. Anyways, that has been all for this video, and I hope to see you in the next video, which is level design in the Unreal Engine. It's mostly going into theory, but there's a lot of actual concrete information as well that you'll learn. But don't be shy about the theory. It's very important, something that many new level designers neglect to look at. Thank you very much.